Hello and welcome to this webinar by AFRY Management Consulting on Nordic and Baltic energy markets. So I'm Henrik Tegnér. I'm based in Stockholm, Sweden. I'm responsible for AFRY Energy Management Consulting here in Sweden. And I will do this seminar here today together with Stephen Woodhouse from our Oxford office in the UK. And just as a start, we will be sending out the material after the meeting to all of you attending, and also a recording of this session. So the subtitle for this session today is Nordic and the Baltic energy markets and the near future. And we will start by talking a bit about the current situation in the next 6 months or so. And then we will move over to talk a bit about the effects on the energy transition that we can see from here and until around 2030 or so. And some of you maybe think that this is not the near future, but we mean that in order to manage the situation, we need to start taking action already now in order to have an energy system that delivers on decarbonization, that provides a security of supply of the energy, and where anyone who needs energy actually can get access to it when and where they need it, or more or less at least. And finally, we need to do all of this in such a way that it is cost efficient, so that the Nordics and the Baltics companies and society can remain competitive compared to other parts of the world also in the future. So if we start by looking at the current status of the Nordic power market, we have prices that at the moment actually are mainly driven by the weather situation. And that has been pushing prices downwards in the first part of this year. So the fact that we have a mild winter in combination with wet weather has filled up the hydro reservoirs, and there's a lot of hydropower available. And in addition, there has been very good conditions for wind power, and we've also added a lot of wind power in the last year or years. So that's a temporary weather situation, but then we have also the corona situation and other global drivers like the oil price, for example. And they are also important, but clearly right now the main drivers are the weather effect and not the corona effect as such. And of course, the current weather-related effects are not long-lasting. They're not affecting the prices in the long run, but for the next 6 to 9 months or so, while the reservoir levels stabilize, of course, depending on the weather going forward. And looking then at one slide too far, looking at the price levels right now, you can see the solid line is the price for the first weeks of this year. And you can see that it's quite a bit below where we have seen it in the previous years, which are the curves above. And perhaps you can even recall that 1 year ago, the situation was very, very different, where we had a dry situation, less precipitation and low reservoir levels, and thereby also a lot higher prices. We also mentioned grid capacity as one of the drivers here. Of course, since grid capacity to areas outside the Nordics and the Baltics are determining how much we can harmonize prices with the rest of Europe. Currently, there is a limitation towards Germany, for example, that makes prices quite a bit higher in Germany than in Sweden, especially. But more grid capacity would also have a lot of effect on the prices across the Nordics and Baltics. So right now, if we look, for example, at last week, the price, as you can see, is very low here, about €5 per megawatt hour as the system price. And in Norway and northern Sweden, it was actually a little bit less than €5. In south of Sweden, it was nearly €9. In Denmark, it was between 11 and 16 euro. And in Finland and the Baltics, it was over 20 euro per megawatt hour. So it's more than 4 times higher in Finland and the Baltics compared to the system price. And that is mainly then driven by constraints in the grid capacity within the Nordics and Baltics. We can also see that there is quite a lot of volatility in other commodities. So of course you have seen the oil price, and that is not an effect of the corona situation either. It started before the corona, the drop in the oil price. But we see quite a lot of volatility now in the different commodities. So here you can see the oil, the gas and the coal, but also then the carbon price. And that's something that can be expected to continue for a while. And if we then look at the impact on electricity consumption in the Nordics, because that would be then another interesting parameter in relation to the shutdown of the countries that we have now. It's actually not so much of an effect yet. So you can see again, the solid line is the 2020 numbers, and you can see that it starts off a bit below the other years that we're comparing with, but that's then mainly driven by a warm winter, so less consumption because of a warm winter. And then it drops off the consumption as a result of less heating demand when we move into spring. But it's not really below any of the other years yet. Maybe in the last week it's actually dropping a bit, so not dramatic, and we need to see how this moves going forward. But this could, of course, then be a factor that would lower the prices even further going forward. So that's something to monitor. But that's enough on the short-term situation, and I will now hand over to Stephen for the slightly longer-term discussion. Over to you, Stephen.
Henrik, thank you very much. So I'm Stephen Woodhouse. I work in the Oxford office, or at least when I'm in the office. I've worked on our market design and policy work for 20 or so years. And because I still believe in markets, I've done more and more work. I've done much more work in the Nordic and the Baltic region in the last 5 years, I think, than anywhere else. So although I'm not a Nordic market expert, I know quite a lot of the details. And we've been working for a bunch of people recently in different contexts, looking at what feels like quite a near future. So looking at 2030 on the pathway to the full decarbonisation. So we're looking at the implications of the energy transition. And a lot of people have been saying that we're moving much more towards a world where no more support for renewables is necessary. If you just look at simplistic measures like levelized cost, the cost of renewables is collapsing to be competitive with conventional generation. We're moving into a zero subsidy world. But actually, I think it's the opposite. I think if you look at the aggressive targets we've got in many countries for very high renewables penetration and for very strong decarbonisation policies, by 2030, the policy risk and the policy issues are actually going to be more dominant in the next 10 years than they maybe were in the last 10. So let's go through the story and you'll see how much you agree with that thesis. So we're now focusing on the Nordics and the Baltics. If you look at the Norwegian system, the electricity system is virtually fossil-free, carbon-free already, but we're now going beyond that towards looking at decarbonising the entire economy. But there is no system in the world as well placed as the Nordics to be able to migrate to that decarbonised economy using cheap electricity as a vector for industry, for transport and for heating. So there will be challenges, of course. It's not immune from problems. Big topics will include bulk transfer of electricity from north to south of the region, ongoing issues around the decommissioning of the nuclear and the thermal and the flexible assets. And you might say that's a capacity issue. You might say it's a flexibility issue. In particular, in the southern and eastern areas, there are concerns about access to balancing capacity and flexibility. Fingrid has a concern about that already. Looking at a future scarcity of network capacity to meet development needs. And in some key cities in Sweden, this is already headline news. So both Solna, but also Malmo, you're reading headlines about people not being able to get capacity for property development and for, I think there was a bakery that couldn't expand with 300 jobs. So grid capacity is a problem. And the operation of the system under very high renewable shares, looking at inertia and fast frequency response, we're moving into unknown territory here. So things are being done to deal with these challenges. So there's a new Nordic balancing model being developed. There's a consultation now on reconfiguring bidding zones, I think with a separate zone around Stockholm under consideration. And I will say limited grid reinforcement. It doesn't feel like enough is being done in that area. And this is 2030 we're talking about, and I'll show you that in a minute. That's tomorrow in terms of investment. And some of the grid requirements, some of the hydrogen related decisions essentially have to be made immediately in order to achieve some of the 2030 and near after timeframes. So I won't go through the detail here, but we're no longer talking about decarbonisation by 2050. Denmark's looking at 70% decarbonisation of the whole economy by 2030. Finland wants to be carbon neutral by 2035. And there's a cascade of issues beyond that. So we're talking about things that are much, much sooner than 2050. If you look at the scale of the carbon reductions, again, they're quite eye-watering. And it goes way beyond the power and heat, which is only generating a share of the emissions. It takes us deep into industry, agriculture, transport, and other sources as well. So really, we need to be using electric and hydrogen or some other vector to decarbonize heat transport and to a great degree industry. So this is just a summary of some of the challenges that we see. So let me start with the big one in the middle, offshore wind. The European Commission's pathways have cases with 500 gigawatts of offshore wind by 2050. And a huge amount of that is likely to be in the areas of the North Sea and the Baltic Sea. And for sure, the Baltic Sea is the next area where we've got cost-effective development of onshore and shallow offshore wind. And we know Denmark has very big ambitions as well for offshore development. Lot of wind build out in the north of Sweden and Norway, and a huge number of projects that have passed their final investment decision stage if they can get the grid access. We're talking about new forms of load, so big data centers, but looking at the Fossil Free Sweden initiative, looking at potentially, this hybrid steel production, and maybe we get into electrolysis before long. So talking to somebody from Sweden last summer, they were saying, we need a series of sites throughout Sweden with grid capacity for 300 to 500 megawatts of new load that doesn't exist at the moment. So maybe we need to start thinking about strategic planning for that. So looking at the range of issues, we've clustered them into issues that face generation, question marks over demand, concerns over grid access, and then points around flexibility. So going around clockwise, can we get flexibility from the demand side? What is the nature of the large demand increase from electrification of industry and of heating and transport? We're already having generation adequacy concerns in Finland. In fact, the strategic reserve was increased recently. There's scarcity of grid connection in Sweden and other places. Oil shale decommissioning in the Baltics. Big topic, the Baltics are synchronizing to Europe and desynchronizing from Russia. So that will create a whole new marketplace for flexibility services. We've already mentioned on the call these ongoing grid constraints between Sweden and Denmark and Germany. So blocking the access of Nordic renewable energy to the continental market. Actually, with my market design interest, I'm much more interested in not the amount of interconnection, but how much of it is used for intraday and balancing. So not just to sell bulk energy from the Nordics to Germany, but to sell valuable flexibility. And I think this is the next wave of market design challenges. Renewable forecast error will grow as we get more and more renewables on the system, but that's sort of a known unknown. The point about interconnectors being committed day ahead, I've just been talking about. I know in Norway there are various proposals to allocate some of the grid capacity to balancing services, but we seem to have forgotten intraday in that. So the coordination of an offshore grid and who takes responsibility for that is a big topic. The elephant in the room, the timing of nuclear decommissioning in Sweden. And also, as we electrify heating and transport, if we don't have the arrangements in place fast for valuing the flexibility, maybe we build assets without flexibility that would be needed in the medium term. So making sure we don't lock in flexibility in unnecessarily. And we've talked already about the north-south bottlenecks and system inertia needs. Well, it's not a new subject in Sweden. I had a conversation with some people in Uniper in Stockholm probably 4 years ago, and we were talking about inertia then. In fact, I think Uniper had even had a video showing the quality of electricity, and it wasn't directly about inertia, but it was one of the key topics. So a huge range of issues that merit discussion and proper analysis. So looking forward to 2050, because the 2030 worlds have to be compatible with the longer term aspirations, we're looking at perhaps 3 clusters, one of which we sort of electrify everything that moves. And of course, that's the fastest one to do quickly. The second one relies a lot more on hydrogen and decarbonized gas of one form or another. That probably takes a little bit longer to achieve. So maybe it's not in the next 2 years, but the decisions certainly have to be. And the third alternative world is a decarbonized world, very heavily based on burning biofuels. I have difficulty believing that that can be a huge part of the decarbonization, but for sure it has a part to play. So looking towards those worlds, without coming back to where we are today, and seeing this wave of committed on and offshore wind generation projects. So this is growing fast, and as a commercial consultancy, this is one of our core areas of work, helping companies look at the revenue projections and the cannibalization expectations. So this is happening pretty fast already, but it drives a surplus of energy in the northern areas, high utilization of the interconnection between north and south in those zones, and a shortage of flexibility as it squeezes out generation in the south. So we see an energy surplus in the north and in parts of the west, and a flexibility deficit in the south and the east. And really that does include the whole of Finland. So how will the network be able to accommodate all of these changing needs, not just for capacity, but flexibility, I think is one of the really big topics. And let me build up a story about flexibility. So we're looking at flexibility in 4 different time frames. There are the real-time issues around flexibility, so that's reserve, response, load following, and maybe even inertia. Lots of countries are now developing new products. Ireland has an inertia product. Plenty of countries have fast response products with 1 second activation. And I know these are under discussion now, both in Norway and Sweden. So there's a real-time flexibility need, which is really about immediate actions. There's intraday flexibility needs, which are to accommodate the fluctuations, really the demand and wind forecast errors. That's the primary driver. So that's a ramping constraint. We've got a seasonal flexibility problem, which is the traditional Norwegian issue. Do we have enough terawatt hours of energy to meet next winter's peak demand? And with the interconnection of Norway, that hasn't been a serious problem for a long time, but it's increasingly going to be a problem as we electrify heating in Northern Europe. Maybe it becomes a binding flexibility need in the future. And then the next one is the old-fashioned peak capacity scarcity. And of course, the traditional solution to all of these scarcities is if you build a new CCGT or OCGT, you solve all 4 problems, which is why the people who believe in capacity mechanisms from the 1990s think it solves all of the problems. I have a slightly different view on that problem, on that solution. But we're certainly seeing increasing pressure on these different sources of flexibility. So as we introduce renewable generation and squeeze the conventional capacity from the system, we're reducing the supply of flexibility in all time frames. We are increasing the demand for flexibility in all of those time frames. So Olkiluoto will increase the largest loss and have a demand for a new type of flexibility. There are drivers for flexibility in all of these different areas. And the hope is that as we digitalize the energy system, we manage to unlock flexibility from all of these new distributed resources. And again, the one in the middle with seasonal is more about long-term thermal storage and hydrogen. So this is the holy grail that we're looking for, to have new supply sources for the various types of flexibility that we need. And if you believe in markets, it's about identifying the right product definitions and figuring out how we get the contract structures so people can invest in the right kinds of capacity needs. So we definitely see challenges with the very short-term flexibility as we lose conventional sources of generation, and the amount of inertia on the system from conventional sources gets replaced with both photovoltaic and wind generation, which is non-synchronous. So this is one of the areas that we've done a lot of modeling for in Ireland, which is a system 1/10 of the size. We've been working with EirGrid on their definition of new system services, and we're involved in an EC Horizon 2020 project now with EirGrid, looking at the future range of system services. And our modeling of inertia, so we have a market model which is used by all of the Nordic TSOs, but also by National Grid, and we've adapted it to include modeling of inertia and fast frequency response. So in this topic, we've got a team also based in Sweden who are experts on this issue around modeling the understanding of, inertial response and fast frequency response. It means that there will be a transfer of value between energy and between the new types of system services. And I think trying to quantify that will be rather important, because this is the basis that people will have to make investments in plant refurbishments and perhaps storage systems and so on in the future. In the medium term, we are now then proposing a multi-client study to zoom in on all of these issues. So a number of you on the call will have been part of the webinars for that study. We've now got at least 3 clients who've committed to run with the multi-client study. It includes the TSOs from Estonia and from Finland, and one of the energy companies, Helen, also from Finland. And the intention is that we get a cluster of clients together to bring their expertise to bear, to bring our modeling capabilities to bear, to look in some depth at these issues of what will the future energy system look like, what will the needs be for the new topics of demand, how do we appraise the different short-term flexibility needs and the value of the different products, and then how do we look at the medium-term issues around the grid development and the extent to which the grid development itself will be a barrier. So it will include quite a lot of detail looking at the offshore wind and the coordination of offshore wind. That's one of the special interests of Ellering. And we look forward to discussion with the participants. The intention is to start with the quantification of the issues. And then I think quite quickly we will realize that a lot of the issues become policy and regulatory issues. So there's a possible follow-on to the study to start addressing those topics. But we wanted to have a good quantitative basis before we went into the policy and the regulatory topics. So with that, I'd like to hand over for questions.
Yes, thank you very much, Stephen. So if you have questions, you can ask them in the webinar as well, so that you can write your questions if you have any. So please go ahead and do that. And we've received quite a few questions, some before and then some now during the presentation. So I thought we'll have some minutes to take a few of the questions, and then we will try to get back in writing with other questions as well later. And as we said at the start, we will share the material with you later after the meeting here. So I think that there are some different questions on how we see the long-term development, given that we now have the coronavirus situation and a bit dramatic situation in the short run. How is that going to affect the energy transition going forward? And I think that I'll start to answer this and you can continue, Stephen, but I think that for sure we see that there are some short-term effects, that some investments are now being delayed or postponed, so investments are probably going a little bit slower in the short run. For the long run, we see that it's very, very much a question about the policy response to this from politicians and others, because of course you could now take the opportunity to make this into an opportunity to invest more in green and the energy transition to a decarbonized world. So maybe rather than spending on polluting sectors, you could try to spend in the rebuilding phase on new and green sectors.
There was
anything to add on that? Yeah.
There was a brilliant article by Michael Liebrich, who was one of the founders of Bloomberg New Energy Finance over the weekend. And he was saying exactly this, Henrik, that there will have to be a massive government-led fiscal stimulus to rebuild the economy. So why not spend it in the right places? And he gave an example. He said, instead of throwing money at the car sector, to pay for workforces who are not working, throw them a wall of demand for new electric vehicles instead. So put the money into the local authorities and get them to go and buy electric buses for these companies. So it was just an example. It's a really, really good read if anybody hasn't seen it. But it's just an example of how you can turn a crisis into an opportunity.
Very good. Then if we move then to the next question, there's been some on the cross-border cooperation here in the Nordics and the Baltics, and the view on that, how much is needed and what can be expected in terms of cross-border cooperation. And Stephen, maybe you want to answer that one.
Yeah, I like that question. We did a very interesting project for Fortum last year, looking at the behavior of the 4 Nordic TSOs and the circumstances when they act in a Nordic interest and the circumstances when they act in a national interest. It was actually one of the most fun projects I've ever done, and I got all kinds of interesting stories because I went around the Nordics listening to people tell tales on their neighbors. It was very interesting. And the conclusion of the study is that in normal times, the operation of the system is very collaborative. I got told that the system operator control rooms would give their little fingers for each other. And then the guy said, in peacetime. So when there are difficulties, it becomes much less transparent. I think there are even some standing urgent market messages that the capacity on a particular border is somewhere between 0 and 5,000 megawatts, which isn't a very helpful measure. And that the transparency towards the market was also pretty bad. So collaboration in normal times, okay. Transparency, not brilliant. Collaboration in difficult times, not so good. And the real difficulty is collaboration on investment projects is actually not very good at all. There's a lot of room for improvement on that. So there's the report is published by Fortum. I can send a link if anybody wants it. And the other area we've been looking at is how the capacity is actually used and whether there are opportunities to make some of the network capacity available for the intraday and the balancing services, which is where the Nordics really have a competitive advantage. And if the interconnected capacity is basically all used up day ahead, it's blocking the ability of the Nordic area to sell its flexibility to the Baltics, which will need flexibility when they desynchronize, and also to Germany. So I think there are some big policy issues there.
Yeah, thank you for that, Stephen. And we're almost at the half past here now, so we maybe have time for one more question. And you touched briefly on this, but there has been some questions on capacity markets. And do you want to elaborate just a minute on your view on capacity markets, if that is needed in order to manage the flexibility needs and the capacity needs going forward?
Yeah, certainly. So I've been part of a team that has taken capacity markets out of a market. I've been part of teams that have designed and built and implemented capacity markets. We even created our own concept for a capacity market called a decentralized reliability option. So I get involved in designing markets around the world. The market design has to suit the circumstances. I don't believe that there's a right answer. Having said that, I don't believe that a capacity market in the Nordics is necessarily the next step that you would look to. So traditionally, Norway, which was the designer of the Nordic market, didn't have a peak capacity problem. It had a winter energy problem if it ever had a problem. So there was no scarcity of capacity. There was always enough megawatts to meet the peak. It was about when you have the energy. The Baltic region has enough capacity on imports to meet its needs without running any generation within the Baltics itself. So capacity may not be the actual problem, but increasingly I think we're seeing that flexibility of various timeframes is the problem. And the difficulty with the capacity market is not all megawatts are the same. I think it becomes important to recognize that different types of megawatt have different capabilities and they all have a different value. So if you end up defining your capacity market around a lowest common denominator, it probably doesn't meet the right needs. But if you then start defining it around lots of different flexibility services, it becomes such a regulated instrument that it's impossible to make an investment on. I give an example. In Britain, we created a capacity market around the assumption that the grid operator would give a 4-hour warning before they had a problem. And we had a blackout this summer. And of course, like every blackout, it happens when a plant trips. This one happened to be because of lightning strikes. So you didn't get 4 hours warning and the lights went out. Now, what I was expecting to happen was that the Secretary of State would have said, what happened yesterday? We're paying some billions that would never happen. And then somebody would have to explain to him that it was set with a 4 hours warning. And he would say, then next time we're not going to give 4 hours warning, the contract say 10 minutes warning or 1 minute warning. So the whole nature of a capacity scheme for me is quite inherently flawed, especially when the value of energy is what you need to make the market coupling work. And I think the future energy system is one with a diversity of resources that won't look like things that will get a capacity payment. So I'm hoping we end up with more innovative solutions than capacity payments, even if they're a necessary stopgap in some places.
Thank you for that, Stephen. And I see that we're now past our time here, so I think we should end here. But I would like to thank all the participants for joining. It's been much appreciated. We do have some questions remaining, so we'll go through those and we'll see if we have the opportunity to respond also in writing to at least some of them. I think a lot of them have been covered one way or another, but I think that there are some remaining. And for sure, we will send out the material afterwards as well. So thanks a lot, everyone, and bye-bye.